Okay, so today we are going to start with the test for cations and anions. When we have to test the cations, we actually use either aqueous sodium hydroxide or we can use aqueous ammonia. These two chemicals or substances can be used as a reagent when we have to identify which cation is present in the solution. So basically, these two, whether it's sodium hydroxide or aqueous ammonia, both produces hydroxide ions. And when these hydroxide ions are released, these hydroxide ions combines with the positive ion to form the hydroxide of that metal. And as the hydroxide of that metal is water insoluble, so it forms a precipitates. And by the color of that precipitate, we can able to identify which cation is present. For example, let's see how we will perform it. For example, there is a sample solution in a test tube, and what we did initially, we add few drops of sodium hydroxide in it. Okay, till here, is this clear to all of you?
Sir, I didn't get the last pointer.
सर आप प्लीज
Basic-
वापस रिपीट कर देना
Basically, these two substances produces this hydroxide ion, okay? And we have discussed the solubilities of the hydroxide ions as well. The cation present in the solution, if it forms a insoluble hydroxide, then that hydroxide combines with that cation to form a precipitates. As it is water insoluble, so it doesn't stays in the solution. Instead, it comes out and forms the solid particles, which we call precipitate. And by observing that and the color of the particles and further solubility of those particles in excess sodium hydroxide or in excess ammonia, we will able to identify which positive ion is this. For example, if I'm talking about this sample solution must contain an unknown positive ion, right? So when we add a sodium hydroxide or aqueous ammonia in that solution, these both solution produces hydroxide ion, and those hydroxide ions, when combines with this metal and form the hydroxide of this metal, then that hydroxide is water insoluble, and as a result, it will form a precipitate. Now, is this understandable?
Yes, sir.
Okay, so there are 6 different possibilities when we add few drops of sodium hydroxide in aqueous solution, in that sample solution. So the first possibility is that on adding sodium hydroxide, there the solution stays colorless. There will be no change in the solution. Okay. The second possibility is that we are going to observe the white precipitates. The third possibility is that we are going to observe the green precipitate. Fourth is that red-brown precipitates are formed, and fifth one is light blue precipitates. Okay. So just complete till here, then I will discuss further that how can we conclude by the color of the precipitates of the solids. As you complete this, let me know. Yes, are you guys done with these points?
Yes, sir.
No, sir, just a minute.
Okay, please do it quickly.
Sir,
Yes,
should we complete the sample solution too, or you gonna explain that
which one?
sample solution in the test tube?
I have explained that what we are going to do, we are going to take a sample solution in the test tube, then we are going to add few drops of sodium hydroxide. On adding few drops of sodium hydroxide, we are going to get a observation, one of the observation out of these 5. Okay.
So, sir, how are we supposed to know the कौन सी observation होगी?
It depends on the cation present. For example, okay, first tell me if you guys are done till here.
Done,
Yes.
sir.
Okay, now it depends. For example, yeah, if on adding sodium hydroxide, we will observe there is no change in the solution. Then what we are going to do next? We are going to heat it, and on heating, ammonia gas will produce, and we can check it by keeping the damp red litmus paper. Damp means a moistened or wet litmus paper. As the if the gas releases, it comes in contact with that litmus paper and turns it blue. And if this all happens, then we can conclude that the sample solution contains ammonium ion in it. Is this understandable?
Yes.
Yes, sir.
Okay. Now, in the same way, if we added few drops of sodium hydroxide in the aqueous solution, and now we observed that there are white solids form in it, white precipitates in there. So it means that there is the possibility that it may contain calcium ion or aluminium ion or zinc ion. So for that, what we will do next? We will add excess sodium hydroxide in it. So when we add excess sodium hydroxide in it, and if the precipitate dissolves, the white precipitates which form, if they dissolve, then it means that it may contain aluminium or zinc. And if on adding excess sodium hydroxide, the precipitate doesn't dissolve, it means that it contains calcium ion. Is this understandable?
Yes.
Yes, sir.
Okay, now on adding few drops of sodium hydroxide in the sample solution, if we get green precipitate, then it means it have a iron 2 positive ion or a chromium 2 positive ion. Then what we will do, we will add excess sodium hydroxide in it, and on adding excess sodium hydroxide, if the precipitate remains, they didn't dissolve, it means it contains a iron 2 positive ion. And if we keep the solution, so the surface of that precipitates turns red brown as iron corrodes the color, you will see that same color you are going to observe over here. And if the precipitate dissolves, then it means that is chromium 3 positive ion. And if you have added a few drops of sodium hydroxide in a sample solution, and now you observe red brown precipitate, it means there is a Fe3 positive ion. We again add excess aqueous sodium hydroxide in it, and precipitate remains insoluble. It confirms the presence of iron 3 positive ion. Then after this, for example, we have another sample solution and we have added few drops of NaOH sodium hydroxide in it. And on adding light blue precipitates are formed, it means there might be a copper 2 positive ion. We add excess sodium hydroxide on it again, and the precipitate remains insoluble. It confirms the presence of copper 2 positive ion. Is this understandable to all of you?
Yes.
Yes, sir. Sir, I have a question.
Yes.
That in second, when white precipitate will be formed,
Hmm.
at the result we are getting aluminum or zinc. So how will it be distinguished between aluminum or zinc?
Very good. That will be distinguished further by using aqueous ammonia, which I will explain it in the next chart. With sodium hydroxide, we can distinguish between calcium and aluminum or zinc. So we can identify calcium from here, and then we have a conclusion that it is either aluminum and zinc. If we have to further confirm it, whether it's aluminum or zinc, then we will use it aqueous ammonia.
Okay, sir.
सर
Yes.
हमें ये जो सैंपल सॉल्यूशंस हैं तो ये हमें याद करने पड़ेंगे ना.
Yes. Okay. Yes, everybody completed till here?
No, sir.
सर Cr पे +3 का चार्ज होता है या +2 का चार्ज होता है?
It's 3 positive.
ओके सर, वो ऊपर लिखा है 2, नीचे लिखा हुआ है 3 पॉजिटिव।
Yeah, it's 3 positive.
ओके
Just give me a minute. Let me confirm. Basically, chromium is a transition element. So it have a variable oxidation number. Yeah, but here we have 3 positive charge. Okay.
ओके सर।
Yes, is everybody completed till here?
यस सर।
Yes, Mujtaba and Mustafa.
Sir, I'm on the last one. सर आप आगे करा दें, बाद में कंप्लीट कर दूंगा।
Okay,
सही
okay.
है।
Now we have C. In this case, we have a simple solution. And in that simple solution, if we added few drops of aqueous ammonia, white precipitates are formed, then it means it is either aluminium or zinc. And if we add the excess aqueous ammonia, if precipitate doesn't dissolve, then it's aluminium. And if precipitate dissolves, then it's zinc. If on adding few drops of ammonia in a sample solution, if we will get the green precipitate, then it means it's a iron 2 positive ion or a chromium 3 positive ion. Adding excess ammonia, precipitate remains insoluble in both the cases. But with iron, if there are iron 2 positive ions, then the surface becomes red brown, and in case of chromium 3 positive, there will be no change in the color of the surface. If we add aqueous ammonia in a small sample solution, we get the red brown precipitate, which means that there is a iron 3 positive. On adding excess aqueous ammonia, they doesn't dissolve, the precipitate remains insoluble, so iron 3 positive is confirmed. Here, on adding aqueous ammonia in a sample solution, if we will get the light blue precipitate, then it's a copper 2 positive ion. On adding excess aqueous ammonia, these precipitate dissolves to give you a deep blue solution, which indicates the copper 2 positive ion are confirmed. If there is a calcium ion and we added aqueous ammonia, so either we are going to observe no precipitate or very slight white precipitate, very slight precipitates are formed. So do this completely. This whole chart is explaining what you are going to observe with aqueous ammonia, okay?
And sir, if we will add sodium hydroxide and calcium 2 plus, then
we will get the strong white precipitates. There are so many white precipitates, and this remains insoluble in excess.
okay.
Yes, everyone completed.
Yes, sir.
Okay, if you guys take the screenshot, so I will discuss the rest of the tests. So we will end all the tests in today's class. Please take the screenshots.
Done, sir.
Okay. Just give me a minute. Okay. Now, as we have seen the different precipitates, white precipitates with calcium, zinc, and aluminium, and green precipitates with chromium and chromium 3 positive ion and iron 2 positive ion, and the red brown precipitates with iron 3 positive ion, and the light blue precipitate with the copper ion. So those precipitates are formed due to these reactions. Here we have written the ionic equation, and sometimes examiner asks you to write the ionic equation when the white precipitates of calcium will form, when the green precipitate of chromium will form. So you have to know all these ionic equation. Is this clear?
Yes, sir.
Okay, complete this, please. Or
Sir,
take the
screenshot,
screenshot.
sir.
Yeah, take the screenshot, please. So we'll continue further. Yes, everyone done with the screenshot?
Yes, sir.
Okay. Now we have a test for anions, the negative ions. So there are these 7 negative ions for which examiner asks you the test: the carbonate ion, chloride ion, bromide ion, iodide ion, nitrate ion, sulfate ion, and sulfite ion. To identify a carbonate ion, we can use any dilute acid. So the unknown sample, we add dilute acid in it. We will see the bubbles of the colorless gas. If we pass those bubbles through our lime water, these bubbles turns lime water milky. If this will happen, then it means that the sample solution contains carbonate ion. Is this clear to all of you?
Yes, sir. Sir, it means it will produce the carbon dioxide, right?
Yeah, that's why the gas is carbon dioxide over here. Okay. When we have to identify the chloride, what we will do for the identification of chloride, we add dilute nitric acid, then we add aqueous silver nitrate in it. We will get the white precipitate, and these white precipitates indicate that there is a chloride ion in the sample. When we add a dilute nitric acid in the sample and then add aqueous silver nitrate in the sample, the same thing that we have added for chloride, if we do the same reagents, if we add the same reagents, and instead of white precipitate, if we get the green precipitate, then it means it's a bromide ion. And if we do add the same precipitates in the sample, dilute nitric acid, and then silver nitrate, and if we get the yellow precipitates, then it means it's an iodide ion. Till here, is this understandable to all of you?
Yes, sir.
Okay. Now we have a nitrate ions. So to identify the nitrate ion, we add aqueous sodium hydroxide, then we will add aluminium in it, and the aluminium foil, and then we warm it. So we have to mix 3 things, do 3 things: adding aqueous sodium hydroxide, then aluminium foil, and then warming. It will gives us the ammonia gas, and ammonia gas turns damp red, litmus blue. If all this happens, and if we observe these observations, then we can conclude that the sample contains nitrate ion. Same for the sulfate ion, we add dilute nitric acid, then add aqueous barium nitrate in it. And on adding aqueous barium nitrate, if we get the white precipitate, then it's sulfate. So see, sometimes student mix these two tests. Here we are adding aqueous barium nitrate and we are getting white precipitate, that is for sulfate. And on adding aqueous silver nitrate and we are getting white precipitate, then it's for chloride. Is this clear to all of you?
Yes.
Okay. Then last we have a sulfite. To test the sulfite, we add acidified potassium, aqueous potassium magnate 7 in it. On mixing acidified potassium magnate, the solution turns purple to colorless, which indicates there is a presence of a sulfite ion. Yes, can anyone recall what else we used to test potassium magnate, acidified aqueous potassium magnate? Yes, can anyone recall? We use it for the reducing agent. To identify the reducing agent, we use this same reagent. Okay, take the screenshot, then we will continue further.
सर कौन से वाले के लिए हम सेम रिएजेंट यूज करते हैं?
This acidified aqueous potassium magnate is also used for to identify the reducing agent as well. Okay, everybody took the screenshot?
Yes, sir.
Okay. Now, these are the tests for gases over here. You have to remember all of these tests. When we have to test the ammonia, we will hold the damp red litmus paper over the mouth of test tube. And damp red litmus paper turns blue. This will be the observation. For carbon dioxide, we will pass the gas through lime water turns milky. For chlorine gas, we hold the damp litmus paper on opening of the test tube. That litmus paper bleaches, which means it decolorizes. That indicates there is a chlorine gas. For hydrogen, we use or hold a burning splint on the mouth of test tube that produces pop sound. This indicates the presence of hydrogen gas. Then we have oxygen. We will hold glowing splint on the mouth of test tube. See, understand the difference between burning splint and glowing splint. Burning splint is the splint in which there is a flame over here. It is with the flame. And the glowing splint is the one when the flame is extinguished and that tip is hot red and it shows the red color. And when we introduce it, it relights. It means in the presence of oxygen, that tip again catches the fire and gets the flame. So for hydrogen gas, we use burning splint, which produces a pop sound in hydrogen gas. For oxygen, we will use a glowing splint. and it relights. For sulfur dioxide gas, we pass the gas through acidified aqueous potassium magnate 7 and the solution turns purple to colorless. Are all these tests clear to all of you?
Yes, sir.
Okay, take the screenshot. Yes, everybody done? Everybody took the screenshot?
Yes, sir.
Yes, sir.
Yes.
Sir, can you please tell once again that what is meant by bleaches here?
Decolorizes.
Okay.
Okay. Now, there is a flame test. So you have to remember the flame color of the cations, as lithium shows red, flame color, sodium ion shows yellow color, yellow flame, potassium ion shows lilac flame, calcium ion shows orange red flame, barium ion shows light green flame, and copper 2 positive ion shows blue green flame. Take this screenshot.
Sir, what is meant by the flame test?
I will explain the method, then you will understand how we will do the flame test. Actually, we burn that compound in the flame, and on the presence of these ions, the color of the flame changes. And these colors are shown.
Okay.
Everyone took the screenshot?
Yes.
Okay. Now, this is the method. What we will do, we will make a loop of a wire. We dip the wire in the solid sample, so some of the solid particles stick to the wire loop. Then we put the loop on the edge of the blue flame. We always keep the flame blue, and then we will put the loop to the edge of the blue flame from the Bunsen burner, and the color of the flame is seen. So the color varies. If it's orange red color for calcium, it's lilac color for potassium, it's yellow color for sodium. Is this understandable to all of you?
Okay. Yes.
Okay, everybody please took the screenshot.
Sir, in the while loop, only I mean the whole compound will be attached, right?
No, no, no. We see the compounds are usually in the powder form. So when we dip the wire loop in the compound, so some of the particles get stick with the wire loop.
Okay. Okay.
And then we uh, introduce it to the edge of the blue flame from the Bunsen burner.
Okay, sir.
Yes, anyone want to ask any other thing?
सर ये मुझे मेथड लाइक सर मुझे समझ नहीं आ रही
Hmm?
कैसे होगा डिप वायर इन सॉलिड सैंपल
Can you repeat again what you were asking?
सर मुझे समझ नहीं आ रही फिजिकली कैसे करेंगे मैम.
The best way to for this, you can just search on YouTube the flame test, so you can see basically this is the wire loop is like this. So when we dip this area in the solid, so some of the particles get attached to it. Then this is the Bunsen burner. We burn it. When the flame is blue, we introduces the wire loop over here to the edge. So as the solid burns, the color of the flame changes.
Okay, sir.
Further, you can WhatsApp, you search on YouTube, so you will see the actual video where someone is performing this flame test.
Okay.
Okay, so we'll be ending the class over here, and now we will meet in the next class on Tuesday. Okay.
Okay, sir. Allah Hafiz.
Okay, take care, everyone. Allah Hafiz.